Hi, student. How are you? Welcome to our session on the cube root function. Here is our function, y equals the cube root of x. Let's substitute some values into our function and we'll graph some points. We'll take the cube root of -8. The cube root of -8 is -2. -8 comma -2, our first point. And the cube root of -1 is -1. Then we get our second point. And the cube root of 0 is 0. And the cube root of 1 is 1. The cube root of +8 is 2. And the cube root of 27 is 3. And we get a couple more points on our graph. And 8 comma 2 and 27 comma 3. All right, let's graph these points. -8, -2, -8 comma -2, -1, -1, 0, 0, +1 up 1, 8 up 2, and 27 comma 3 is not going to fit on my graph. That's okay. We will get the general shape of our graph. And we see that the domain left and right, we will go on forever to the left and to the right, -infinity to infinity. We have no domain restrictions. We can substitute negative numbers into the cube root and we will get a solution. The range. This graph does continue up forever to +infinity. It also continues down forever to -infinity. All right, let's take a look at the transformations of the cube root function. And here are our transformations. Starting with A. When A is negative, the graph is reflected vertically over the x-axis. When A is greater than 1, we have a vertical stretch. And when A is a fraction in between 0 and 1, we get a vertical compression. Horizontal shift left and right. Horizontal is the opposite of what you would think. The cube root of x plus h will shift the graph to the left. And x minus h shifts the graph to the right. Opposite of what you would think. Vertical shift is the plus k on the outside of the radical. Plus k shifts the graph up, minus k shifts the graph down. Let's take a look at some practice problems identifying the transformations. Yeah, you can use Desmos to graph and take a look at a visual representation. All right, here we go. Number 1, the -8 under the radical is going to shift the graph to the right 8. And then the -4 on the outside will shift the graph down 4. Number 2, we have A is -2. Since A is a negative, we're going to reflect the graph over the x-axis vertically. And then a vertical stretch by a factor of 2. The +5 is going to shift the graph to the left 5. And then the -9 on the outside of the radical, we're going to go down 9. A is 1/4. This is a vertical compression of the graph. x plus 12 on the inside of the radical. We're going to go left 12. And then the plus 3 on the outside will go up 3. And then the last part of our session today. Oh, there's the Desmos graphs. The last part of our session today, we're going to take a look at the domain and range, comparing the square root function and the cube root function. The square root function is an even root. We can't take the square root, no square root of negatives. We get imaginary numbers. So the domain of our parent function, square root, is 0 to positive infinity. The range is also 0 to positive infinity. The cube root function is an odd root, so we can input negatives and get out negative numbers. So our domain and range, I should say range, our domain and range, cutting and pasting, are both negative infinity to positive infinity. Let's take a look at these two problems, identifying the domain and range of a square root function and a cube root function. All right. To find the domain of a square root function, we're going to set the radicand, the stuff, the terms under the radical, to greater than or equal to 0. Greater than or equal to 0. Can't have any negatives under the square root. And we'll add 4, and we get x is greater than or equal to positive 4. So that is our domain for this function. The domain for a cube root function is all real numbers, negative infinity to positive infinity. We don't have any domain restrictions. And then we'll do the range. I've left myself no room. The range, we have shifted up 5. So the range for this graph will be 5 to infinity, or all numbers greater than or equal to 5. We'll put that, we'll leave that right there for the range. The range for a cube root function, it's going to continue up and down forever. So once again, all real numbers, negative infinity to positive infinity. So it's really the square root function that you've got to look out for domain and range issues. Domain and range of a cube root function is all real numbers. And that concludes our session on the cube root function. Thanks so much for joining our session, and I'll see you next time.